Question 3 of the KA4. We've got a bit of a picture here. Figure 2 shows the sketch part of a curve C with equation that ugly thing and line equation 13 minus 2x. Verify that the line and the curve intersect at 4, 5. Now, the easiest way to do this is to sub in 4 to both. So 4 times 4 minus 3, 4 to the 3 over 2 plus 13. Since it is a verify, it's only 2 marks, I'd make it really clear that you know what's going on. So that's 8 plus 13. 16 minus 24 plus 13 is 5. And the other one, 13 minus 2 times 4, 13 take 8, which is 5. And then we need to conclude in these verify, or then that's the verify. You need to say therefore they intersect at 4, 5. Okay. So part B, let's use some colours. Unfortunately you can't do this in your test. So we've got find the region R shown in the figure, find the area. So let's look at the integration first. Because we've got curves and these labelled areas are, it's normally integration. Well, it ends here, we just said that was 4 and 0. Now if I integrate under C, I'm going to get all this. Now that's too much, I don't want all that. So that is the integral under C. Between 0 and 4. Now, yeah, that's going to be fine. What we want to take away is this trapezium. Now we know that its height is going to be, well, we need to find where its height's going to be. It's the easiest way. This line, we can see its y-intercept is going to be 13, so that's where that's going to be. So the height is 13. We know this height is 5. We know this distance is 4. So that is just a trapezium. Or a rectangle and a triangle. Let's do the integration first, because it's going to be worth more marks. So it's going to be from 0 to 4, 4x minus 3x to the 3 over 2 plus 13 dx. So we will add 1 to our power, so we get x squared, and divide by our new. Add 1 to our power and divide by our new. And with a number, we just gained an x. Let's sort these out, make them look a bit neater. Minus 6 over 5, x to the 5 over 2, plus 13x between 0 and 4. Sub in our limits, 2 times 4 squared, minus 6 over 5, 4 to the 5 over 2, plus 13 times 4. Take away. Now some of you will spot that this is obviously going to be 0. Don't get in a habit of just assuming it is, because next year especially it won't be, and it won't be very often. Just going to whack that in a calculator and we get 228 over 5. Okay, now for our trapezium then. So we've already kind of said, oh, I'm running out of space here, zoom in a bit. We've already kind of said we had a height of, I think it was 13, 5 and a distance of 4. So area here is going to be a half a plus b, so opposite sides times 4, 18, 9, 36. So the area we want in the end is going to be the integral take away the trapezium, which is 48/5. Okay, let's mark that then. So, let's pick a different, let's go with green or whatever greeny colour that is. Should we get a better green? Let's get a proper green. Oh, it's not green. So it was M1 for subbing into one, A1 for the other. For the comment at the end, sometimes the M1 was for trying simultaneous equations and getting to x equals if that's how you went about it, but it was really difficult pair of simultaneous equations to solve, to be honest. I wouldn't go for that way myself. Part B here. So 2 of these marks straight away are for integrating correctly. So M1 for adding 1 to a power and dividing by it. A1 for getting all the terms right. And then the last mark is a weird one to give, but it happens a lot now really, where it's for an overall correct method. So it's for doing somewhere this difference between the integral area and the area of some shapes, whether you split it into a rectangle, triangle, kept it as trapezium, whatever you've done. And an A1 for the right final answer. Okay.